Hello and welcome to Maths Table. In this lesson of coordinate geometry section 2.2, we are going to discuss how to find the length and midpoint of a line segment. Now to find the length of a line segment, we can simply apply the distance formula between 2 points. Suppose that we have this graph of a straight line which passes through 2 points P and Q with coordinates x1, y1 and x2, y2 respectively. And we are supposed to find the distance between these 2 points. To do this, we can construct a virtual right angle triangle like this shown by the dotted lines. This consists of an imaginary vertex R with coordinates x2 and y1. Now, in this way, in this right angle triangle, the length PQ becomes the hypotenuse of the triangle, and the other two lengths can be found out by simply taking the difference between the y coordinates and the x coordinates of the points P and Q. Now we know that for right angled triangles, we have Pythagoras theorem. So simply if length PQ is the hypotenuse, then we can apply Pythagoras theorem on this virtual right angled triangle. And in this way, we can get this equation PQ square is equal to x2 minus x1 whole square plus y2 minus y1 whole square. Now simplifying this by taking positive square root on both sides, we can get a final general distance formula for any 2 points, which is the square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is how the formula for finding the distance between 2 points or finding the length of a line segment is derived. Now let's check an example. Suppose that we have a triangle which is drawn on a coordinate graph with three vertices A, B, and C with coordinates shown here. And we have to prove that this triangle ABC is an isosceles triangle. Now we know one thing, that isosceles triangle is a triangle which has two equal sides out of three. So, and we also know that any triangle has three sides. So for this triangle, we have three sides AB, AC, and BC. Now we can simply find out the length of all these three sides by using the coordinates given. And we can check that if any two of these three sides are equal, then the triangle will be definitely isosceles. So first we'll find out the length of AB, which comes out to be 6 units. Afterwards, we find out the length of AC, which comes out to be under root 45 units. And finally, we'll find the length of BC, which also comes out to be under root 45. So out of these three lengths, these two lengths, AC and BC, are found out to be equal. So therefore, as two of these three lengths are equal, then this triangle ABC is an isosceles triangle. Now the next section is about finding the midpoint of a line segment. Suppose we have the graph of a straight line which passes through 2 points P and Q and a third point M which lies exactly in the middle of these 2 points. So this point M, which is exactly in the middle of P and Q, is called the midpoint of PQ. And if we need to find out the coordinates of this point, we can do this by simply taking the average or arithmetic mean of the x and y coordinates of the original 2 points PQ. So in this way, we can derive a simple formula for the midpoint between points P and Q by taking the average of their x coordinates x1 plus x2 over 2 and their y coordinates y1 plus y2 over 2. So this is a simple derivation of the midpoint of the 2 points. Now suppose that the original coordinates of P and Q are given to you, and these coordinates are 1, 3 and 3, 7. Now we can apply this formula and put these values in it, and hence we can get the final coordinates of the midpoint M, which comes out to be 2 and 5. So this is how we can use the midpoint formula to find out the coordinates of the point which lies exactly in the middle between any 2 points on a straight line. Now here we have a question that there is a parallelogram ABCD which is drawn on a coordinate grid with 3 points A, B, and C given to us. We have the coordinates of these 3 points, but we don't have the coordinates of the fourth point, and we are required to find out this fourth point D. Now, if we have a parallelogram on a graph, we know one thing, that the two diagonals of this parallelogram, which are AC and BD, they share a common midpoint. So if we assume that the coordinates of point D are x and y, and we know that the midpoint of AC is equal to the midpoint of BC, which is basically the same point, then we can use this equation and the formula for the midpoint to find out the midpoints of both of these combinations. So midpoint of AC can be found out on the left side, whereas the midpoint of BD can be found out on the right side. Now we can find the exact coordinates of midpoint of AC because we know their exact values. But for B and D, we don't know the coordinates of D, so we'll have to write the midpoint of BD in terms of x and y. But as we know that this is basically the same point, this means that that 7 plus x over 2, the x coordinate of midpoint of BD, is simply equal to 5, and the y coordinate of this midpoint 6 plus y over 2 will be equal to the midpoint of y coordinate of midpoint of AC, which is 8. Now solving these two equations separately, we can get the values of x and y, which were the basically the coordinates of the unknown point D. So in this way, the coordinates of the fourth vertex D are found out to be 3 and 10. So this is how we can easily use the formula for the midpoint to find out the coordinates of the fourth vertex of quadrilaterals other than parallelogram, even like rhombus, rectangle, square, etc. So was in one of the applications of the midpoint formula. In the end, we would like to thank you very much for your valuable time in watching this video. For any questions or queries, you can contact us directly on our Facebook page or on our Instagram. And for more updates and updates for about new videos, please subscribe to our YouTube channel. Thank you very much and have a nice day.